Ready? Okay. All right, today we're just going to part one, just introducing you to trigonometry. Trigonometry, of course, tri meaning three, gon like a polygon or decagon, three meaning side, and metry like the metric system or geometry is measure. So we're measuring things with three sides. What are we measuring? Triangles. That's all it is. It's a fancy name for measuring triangles. We're going to start off here with just basic right triangles. All the other trigonometry rules come from triangles. SOHCAHTOA is the acronym we use. As long as you know how to spell her name, she will help you. It's great. These are just ratios of sides. The sine of an angle is equal to the opposite side over the hypotenuse. The cosine of an angle is equal to the adjacent side over the hypotenuse. That says sine, S-I-N-E. And the tangent of an angle is equal to the opposite over the adjacent. Now, you want Latin here, sine meaning like sans, I believe, mean without, tangent as into touch, tangible, etc. But all these come back to a right triangle. So if this is angle A, we got to know what's the opposite side, what's the adjacent side, and what's the hypotenuse. Not too hard. The opposite of angle A is going to be this side, correct? Opposite. The adjacent side can be a little bit more tougher, but if you know what the hypotenuse is, well, the hypotenuse is always across from 90, hypotenuse, and so that means this has to be the adjacent side. Adjacent meaning next to, right? This is next to the angle. This is opposite from the angle. How can you tell if is it the adjacent hypotenuse? As long as you know the hypotenuse, you're fine. Right now, we're just going to be getting comfortable setting up the ratios here. We're not solving these yet. We're just setting them up. So I'm going to put some triangles up here. We're going to call this angle B. We'll use a simple right triangle here. 3, 4, and 5. Nice Pythagorean triple. I want to know the sine of B, the cosine of B, and the tangent of B. Give you a few seconds to think about it, and then we'll start calling on these. Mr. Lucas, what is the sine of angle B?
3 over 5.
3 over 5. You are correct, sir. This is the opposite side. That's the hypotenuse. So 3 over 5. What's the cosine of angle B? Mr. Lewis.
Four.
Yes, this is the adjacent side.
4.
4 over 5. You are correct, sir. 4 over 5. And the tangent. The tangent, Mr. Crawley.
3 over 4.
3 over 4. Correct. As long as you can figure out what's opposite adjacent hypotenuse, and as long as you remember SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. tangent is opposite over adjacent. See where SOHCAHTOA comes from now? She's hot, isn't she? She's awesome. All right, I'll give you another one here. Just get this over. This is the opposite. 90, that's the hypotenuse. That's the adjacent. That's angle A. All right, I'm going to throw you a curveball here. We're going to say this is 40 degrees. I'm going to use just letters this time. This is X, this is Y, and this is 7. I want to know what the sine of 40 is, what the cosine of 40 is, and what the tangent of 40 is. Mr. Mozell, what is the sine of 40 here?
X over 7.
X over 7, correct. This is the opposite. This is hypotenuse. I normally like to label opposite, hypotenuse, and that helps me figure out the adjacent side. Once I list those, it's real easy to do from there. So, what do you say for sine?
X over 7.
Ooh, sine is opposite over the hypotenuse. How much is the hypotenuse here?
Oh, X over Y.
X over Y. X over Y. Now we can't solve something with two variables in it unless we have two equations. But fortunately we have other ratios we can use. What is the cosine of 40? Ms. Willover.
7 over Y.
Cosine. Adjacent over hypotenuse. 7 over Y. Correct. Tangent of 40.
X over 7.
X over 7. Awesome. Tomorrow we're going to learn how to actually solve these, but today we're just going to be setting them up. All right? Get comfortable setting them up. Tomorrow we'll actually solve them. You'll need make sure you have a calculator or a phone. Once again, on the test, you can't use your phone, so you might want to even just get comfortable using those. But we'll actually be able to figure out what X is, what Y is, etc. All right? Applications of this, if you've got an angle finder, and you're standing on flat ground, and you're looking up, you got a 40-degree angle, and you know how far away you are from something, you can figure out the height of it. We're going to figure out how tall the stadium lights are. No, we didn't find out how tall the stadium lights are. We found the found the angle. Found the angles. Yes. We're actually going to find out how tall are the stadium lights. Who knows? We'll find out. So lots of applications of this, though. Trigonometry. Even if you don't like doing it, you like the results of it. Because how many of you like your cell phones? I thought so. It uses trigonometry. All right. So this is just how you set it up. SOHCAHTOA, sine, opposite over hypotenuse. Cosine of the angles, adjacent over hypotenuse. Tangent is opposite over adjacent. Bad joke of the day here. Why did what happened when the mathematicians stayed all day at the beach? He was a tangent. Okay.